species that grow in a forest, or the diversity and abundance of mosses and lichens on a single tree. So like questions like this are what have driven me to study some of the few large intact natural areas that remain in Eastern North America. So such as the Appalachian Mountains, an area that I suspect many of you are familiar with because of the Great Smoky Mountains, and where most of these photographs are from, this is part of a large scale project that I've been working on for the last 5 years. So, you know, the Southern Appalachians and the Appalachian Mountains in general are absolutely beautiful, and lichens are diverse and abound there, you know, in ways that they may not in other parts of the United States. But the reality is that, you know, every time I go to these places, I return home to New York City. And I think, like many people, I always assumed that the lichens in my home, as well as other cities in general, had been well studied. But, you know, lichens are well known to be influenced by human activities, and some of the foundational work on that was actually done in New York City by Ernie Brodo. He's a Bronx native. He's now in Canada. He worked for the Canadian Museum of Nature for his entire career, essentially, and he attended City College. So, you know, it was only when my colleague Jessica Allen dug deeper into the story of lichens and New York City and urban areas that she discovered just how little was known, and that there were really almost no resources to actually try and identify the lichens in cities like New York, which to me was just absolutely insane. You know, how is that the case? We have so many resources to field guides, to, you know, birds and plants and so many things. How could something that does grow and occur in our area, you know, be so hard to study? And so that's what I'm really going to talk about today, the urban experience of lichens, and especially as how it relates to New York City. All right, so strap in for the ride. So what are lichens? Lichens are fungi, and they're fungi that have evolved this really specialized, unique lifestyle that involves entering into symbioses with algae or cyanobacteria, so things that photosynthesize, for the purposes of obtaining nutrition. So this is a beautiful lichen, again, from the Southern Appalachians, where I work most of the time. And if you were to cut it open and look at it under a compound microscope, what you'd see is that there's layers of purely fungal tissue, and these encapsulate a layer that has the alga, or the photosynthesizing organism, intermixed with the fungus. And so the alga, or the cyanobacterium, produces nutrition, or produces photosynthates and things which the fungus obtains as nutrition. They're integral to each other, and they cannot survive independently on their own, as far as we know. So lichens are this really unique lifestyle that's evolved in fungi. There's many different groups of fungi that have evolved this lifestyle, but they all enter into these beautiful symbioses that look absolutely nothing like the two parts would if they could grow on their own. So these fungi, if they were able to grow in the environment on their own, they would probably just look like a felty white weft of fungal hyphae on a tree, you know, be pretty sad. The algae, they would look even sadder. It would just sort of be some green scuzz growing on a tree or a rock or something like that. But, you know, they get together and they form these things that are just so utterly intricate and beautiful. It's really a true wonder of the natural world. So lichens are fungi, but they're fungi that are really dynamic and important. So they actually form these really tight-knit communities where lots of different species, closely related ones and distantly related ones, grow in close proximity for their collective and share their microbial floras for their collective survival. So here's a branch from the Great Smoky Mountains, again, where I work a lot of the time. And this is just a selection of some of the species growing sort of close together on this branch. And they're, again, they all rely collectively on each other for their overall survival. They're not just important to each other, they're important to a whole diversity of things, including lots of plants and animals. So for instance, lacewings, this is a lacewing larva that was photographed by my graduate student, Jordan Hoffman, at the New York Botanical Garden and on the grounds of the Botanical Garden. And you can see the little larva puts a little sort of cape or something of dust lichens on its back. Lacewing larvae only use this one type of lichen for that purpose, and that's just one example of many uses by animals and plants of lichens. Probably the most widely known and widely appreciated use of lichens is that the caribou or reindeer rely almost entirely upon them for their winter diets. So plants and animals are not the only things that rely on lichens. They're also incredibly important to the ecosystem. And I think that might be hard to understand when you think about, especially where we live in cities where there aren't tons of lichens everywhere. But, lichens, for instance, contribute importantly to the nitrogen cycle. So when they fall down from a tree, here you have a lichen that fell from a tree and onto the forest floor in the Appalachian Mountains, they die and they rot and they input their nitrogen into the ecosystem. And that might seem like a small contribution if it's, a lichen the size of your palm of your hand, but imagine that in a natural ecosystem, there would be, thousands of metric tons of lichens potentially falling to the forest floor every year. That's a huge potential contribution, and it's not just to nitrogen cycle. There's many different ways that they contribute importantly to ecosystems. So lichens are incredible fungi that are extremely important, both to plants and animals, to each other, and to ecosystems. But they're also incredibly sensitive and threatened. It's ironic that the same lifestyle that's allowed them to really diversify and become abundant all over the globe, including in some of the harshest habitats, the tops of mountains in the Arctic and the driest deserts, this special symbiosis that allows them to occur in these places because they're able to get their food directly from the algae or the cyanobacteria that live inside of them. They don't have to rely on the external environment. That same thing means that they're so specialized that they're very sensitive to changes in the environment. And so that's why, regardless of whether you go to an intact forest on Long Island, you go to Central Park, which is in some areas has relatively mature forest for a city, or you go to the Meadowlands of New Jersey, the lichens in our region, just like in many other cities, have declined significantly in diversity and abundance from what they would have been a century ago. So I think it's really important to sort of think about that as a baseline for the rest of what I'm going to talk about today. That the reality is that the lichens that you see today are declined significantly from what they would have been historically. But that's not all bad. So when we think about lichens, there's really, the lichens in New York City and in our region, as in many cities, is sort of a story that takes place in two acts. The first involves one of vibrant lichen communities that essentially were completely extinguished as a result of urbanization and really air pollution during industrialization. And then a subsequent period, post Clean Air Act, where recolonization has happened and lichens have managed to make their way back into the urban environments where we all live. So New York City has a really rich diversity of lichens, or at least it had historically a really rich diversity of lichens. And there's a lot of different ways that we know about that, but one way that we can study that is from old photographs. And the reason I wanted to highlight this is that I think it's actually a really understudied area of sort of understanding urban lichens, because there's this tremendous wealth of, historical documentation in the form of photographs that exists for New York City and many other cities. Maybe people weren't taking pictures of the countryside and the wilderness 150 years ago or 100 years ago, but they might have been doing that in the city. And a lot of those images have ended up being archived in municipal archives as well as a result. And so, this is an area where people, especially if you're historically or bibliographically or archivally minded, could go and, try to locate photographs of trees and other natural environments where you can actually try to see whether or not there are lichens there, and then correlate the presence of different lichens and their abundances potentially to different times and places. This really has not been done anywhere in the world outside of Scotland. And that was actually not from photographs. That was done from beams of wood that were in old churches that still had the lichens attached to them from when the churches were constructed. Now, this might look like a blurry photograph of someone at Jamaica Railroad Station or near the railroad station in Jamaica in the early 1900s. I think this was the 1920s. But, can you see my mouse? I have to. Can someone see my mouse? Tell me if you can. Yes? Yes, good, okay.
Yeah, we see it, we see it.
Sorry, thank you. This might look like a sort of blurry and a little out of focus, hard to see photograph, But if once you're trained to sort of what to look for the lichens, what you can actually see is that up here in this area of the tree here in the upper right corner, that tree is almost completely covered. The stems are almost completely covered in epiphytic lichens. You can see like a patch, for instance. Sorry, there we go. A little patch here and here and here, maybe there, definitely there, there. You can even see it back here in the background on this tree. Almost certainly those are all colonies of lichens. And if they were a little bit more close up, you might even be able to sort of tell how big they were and potentially what species they might be. It's a relatively limited cohort of things that they would have been in a given region. So you could do that. Anyway, I just wanted to highlight that there is this amazing, sort of potential thing that has not been looked at, which is historical photographs. And actually putting this talk together inspired me to get in contact with the municipal archives. But I think this is something that, anyone could really do, and it really is a potential treasure trove of information. The main way, though, that we understand that New York City once had these really dynamic and thriving, diverse lichen communities is through herbarium specimens, through specimens that were documented by early naturalists. So for instance, these are examples that I like to give. This is from out on Long Island in Southampton. This is the lungwort, Loberia pulmonaria. It's a species that's not disturbance tolerant. It requires more mature forests. And yet here you have a specimen from Southampton collected in the 1890s. The specimen on the right, it was collected in the Palisades, near Gloucester, New Jersey, sorry, not directly in the Palisades, but in northern New Jersey, not far from Manhattan in the mid-1800s. These are conspicuous large lichens that would be the size of dinner plates or even bigger. They form huge colonies on trees. And I assure you that if these things grew in New York City today, someone would have found them and probably documented them on iNaturalist, just because they're so striking. Another great example of this another great example would be this old man's beard, which was collected in Ridgewood, Queens in 1866. Again, this is not a species that you would see almost at all anywhere in New York City. We only recently documented the first occurrence of this genus in New York. It was first found, I think 2 years ago now, in Woodlawn Cemetery, and you can see how big the individual in this collection is. It's probably about that big, and it's robust, and it has lots of fruiting bodies on it. The one in Woodlawn was like this big. And Molly, who is one of the participants in this Zoom, she found one in Greenwood Cemetery the next year in Brooklyn, and it was about the same size. Again, womp womp. They're recolonizing, but the point is that they're nothing compared to what they once would have been. Here's another example. I just put this one in here because it's from guanus, and I think it's just, many people do not associate guanus with, lichens for sure. But it's amazing to see that here's another lichen, a foliose lichen of the genus Xanthoparmelia that was collected in guanus in Brooklyn around the same time in the 1860s. So we have these actually really great data in the form of specimens that exist, but we also have potentially tons of other points of information in the form of historical photographs, maybe even accounts of people writing about parks and natural areas in New York historically. There's a huge amount of research that has yet to be done to sort of reconstruct these historical communities that did occur here. But the reality is that all of these lichen communities were essentially driven to complete extinction due to air pollution. Not just urbanization, but air pollution specifically. And here just are some historical photographs. I mean, maybe not historical for everyone on this call, because one of them is at least in color, but this is what the air used to look like in New York City, as it did in many cities around the United States and around the world. And it's air pollution, specifically the sulfur dioxide and air that came from leaded gas, that resulted in the death of the lichens, because it kills the algae that live inside the lichens and that the fungi then rely on for their nutrition. So we know for a fact that this happened, and that the result was that in most areas you have lost these really dynamic communities of big bullseyes of lichens, that would have been effectively dripping off of the trees, and they've been reduced substantially to sort of a shadow of what they once were. And what that means is that we have this whole host of records of things that we know were here. So we have these beautiful British soldiers, we have these cyanolichens, we have this lungwort, Loberia pulmonaria. These are all photographs and common names, incidentally, from the field guide to the Great Smoky Mountains that was just published in 2020, I believe, from University of Tennessee Press. But I just wanted to, show some photographs of the dynamic and really diverse species that used to occur in New York City. Like, we know all of these were here. Some of them are here today, and I'll talk about that in a minute. But the reality is that what we see is sort of very different and much less than what was once here historically. These old man's beards, I think they're some of the most beautiful lichens. I really love them. This Usnocitraria oxiana. The common rock tripe that George Washington's troops supposedly survived on one winter at Valley Forge. Volpicida viridis, this is a species of cedar swamps. Xanthoparmelia conspersa, this is a species that's actually still found in New York City today. So just a selection of some of the species that we know did historically occur here, and photographs of them that are from modern times. Those are not specimens that are 150 or 160 years old. I wish they were. If they looked that good, that would be something. So, as I said, many of the species were lost. And essentially, you could say that all of the lichens were excluded from New York City by 1960, and primarily as a result of air pollution. That's a very clear connection that's been documented in the literature, and the connection between lichens and air pollution is something that goes back to the 1860s in Paris. So it's a well-known correlation that basically as air quality declines, your lichens disappear. And that's what happened here, as it happened in many other areas. But the interesting thing is that not all of the species have been permanently lost. So for instance, here you have Xanthoria parietina. It probably does not look like very much to you. This is a sad, tiny specimen collected in Flatbush in 1866. It's a bright orange lichen. It's foliose. It's very, very conspicuous, especially if you know lichens. But when it grows abundantly, it's very conspicuous. But this is a species that's still found in New York today. So here are photographs taken by my graduate student in Brooklyn Bridge Park and in Riverside Park. The one in Riverside Park looks a little sadder than the one at Brooklyn Bridge. I can't do anything about that. But, that really begs the question of whether the lichens that we have in New York City today are survivors. So is this an example of a species that somehow managed to survive the air pollution that we had and all of the disturbance, and then now thrive as air quality has improved, or at least, expand its range and expand and grow now that air quality has improved? Is it a survivor, or is it something that's arrived here after the air pollution sort of ceased or got better? And so I think that that's a really important question. We know that we lost almost all of these species, or maybe even all of them. But now what we see today, are these things that made it through, or are they things that have gotten here? Well, I can tell you that we think, and really we have a pretty good idea, that almost all of the lichens that you see in New York City now probably arrived here somehow after 1960. So this is a tree at 22nd Street and 10th Avenue, not that far from where I live. And you can see Xanthoria parietina there growing on a patch of it right there. This was a recently planted tree, and when it came in, it had lots of Xanthoria parietina all over it, and it slowly started to die over the course of a year or two. But the point is that we know with a pretty high degree of certainty that by 1960, the lichens in New York City had been almost completely extirpated and had become regionally extinct as a result of air pollution. But now we have lichens today. And so the ones that are here today have presumably almost entirely arrived somehow. And I think that what's interesting is that a lot of people might think that they've arrived here by being through assisted migration, essentially. Not because people necessarily wanted to move the lichens to Manhattan and other parts of the city. Maybe the lichens wanted to come here, I don't know. But it's more that there's this constant transplantation happening passively by people. People move things into New York City from other places all the time, often without recognizing what's potentially traveling with them. And that's certainly the case for lichens. So here you have some branches that are part of a planter outside an apartment building on, I can't remember, 13th Street, I think that is, near 4th Avenue, near Union Square. These lichens, these do not occur in New York City today. You know, they're abundant on these branches. These came in from somewhere else. And potentially they could establish, right? Here is another great example. This is one that I found earlier in the pandemic when I went out for a walk on the West Side. And I was startled in this art installation that had moved all of these boulders into the West Side Park, into the Hudson River Park. I was like utterly astonished to see these huge, you know, big colonies of lichen. This is a species, Lecanora muralis. There's actually a number of other species growing on those rocks as well. And I was like, why are these here? Of course, all these rocks had been transported into New York City. And so you have now all of these lichens growing on these rocks on the West Side that were not there, you know, whenever this was put in. But what's interesting is that we have this constant influx of things, right? We know that we have this constant influx of new plants, of rocks, of building materials, of who knows what coming into the city. But the reality, and we have lots of lichens that travel with those things. But what's interesting is that even though we have that, the vast majority of them, in fact, I'd argue probably almost all of them, don't actually survive. And this is another example of something that I think is an excellent thing that people can do that has not been done enough, or really at all, in most urban areas in the United States and just generally throughout the world. And that's to follow the course of what happens when you see a new tree brought in and planted, or when you see a rock moved in for a, you know, art installation, something like that. You know, do these things actually survive, or do they not? And so here's an example. This is one that I like to show because it's a tree that is next to my husband's office building. So I follow it, you know, periodically when I walk by, I take pictures. The tree was first planted in April of 2015, and it was brought in probably from somewhere in eastern Long Island based on the lichens that were growing on it. You can see there's patches of lichens here, 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 here. Those are crustose lichens. They look like paint. They're very closely attached to the substrate. And then there's some foliose lichens, some smaller leafy-like lichens. Those are not directly attached to their substrates. They're kind of anchored by things that look like roots, but aren't roots. They don't transport nutrients. But the point is that this tree, it's a little Japanese maple, was brought in with these lichens growing on it in April of 2015. And so I've periodically gone back to follow what happened. You know, by December of the same year, they were not looking so stellar, I assure you. So you can see down here, this one, which is that same individual there, has started to kind of degrade and look a little sad. Same here on this one. So some of them have sort of started to just degrade and not look very good, but they were still there. Well, February of 2020, they were all completely gone. It took a little while, but they did disappear. And so did these species establish, did these individuals establish and thrive in New York City? No, they did not. In fact, they disappeared. Here's another example. This is the common reindeer lichen. This is Cladonia subtenuous. This is the common species in our area that forms these big tufts in the pine barrens of New Jersey and Long Island. What's really interesting is that in Liberty State Park, adjacent to New York City, there's an area, most of the park is developed, right? But there's a small area that is not developed and that has sort of cordoned off. It's actually, I think, a Superfund site. It's contaminated somehow. And so it hasn't been able to be used for anything. And the result is that sort of natural communities have started to establish in there. What has come in? This lichen, Cladonia subtenuous. You can see the little tufts all over on the ground. That's not an example of people having moved it there. That's a lichen that was able to somehow disperse there and become established naturally. So knowing that that's something that can be done, and knowing that that's a species that did occur in our region before, we tried the exact same thing. We tried to move it to the Botanical Garden grounds in 2015. So we put the little individuals of the lichen marked by the red arrows into the base of this tree. And by even a few months later in the same year, they were gone. So, I think that what this really highlights, and this is something that needs to be tested and documented more, and it's something, again, that anyone can do because we're all out walking and paying attention to sort of the world around us in the city. We see when these new trees come in, we see when things come in. We could actually document that over time to see what actually survives and what doesn't. What I would put forth is that the lichens in New York City and in most urban areas, they have to recolonize by adapting on their own. They have to make it here naturally. When they are moved here by people, they mostly, almost if not entirely, don't survive and they die. And so that's really interesting because we know that lichens have increased since the 1960s. Sorry, I'm slowly moving the little face around my screen so that I can see the text on the slide. So we know that lichen diversity has increased after 1960s. So these are some numbers that are taken from a paper that was recently published in the Memoirs of the Torrey Botanical Society. This is a paper that was put together by my colleague Jessica Allen, who really, so she's the one who was like, wow, we don't know anything about New York City lichens. Isn't that crazy? And despite the fact that they are growing in the city today. And so she went and she re-surveyed areas that had been surveyed in the past. So for instance, the Brooklyn Botanic Garden on the right, Ernie Brodo went there in the 1960s as part of his large study of Long Island lichens, and he found, I think, a single species, maybe it was one or two, but not very many. Jessie went back in 2017 and she found nearly 20. Alley Pond Park in Queens, Ernie went there in 1968. He found, some number, not very many, somewhere between 5 and 10. Jessie went back in 2017, found about 15. Two examples where we know there's a very clear increase in diversity from 1968 to 2017. The High Line is a really interesting case because we know that in 2004, there were several species. Jessie went back in 2017, she found only one species. Why was there a decline? Well, the answer is that the High Line became a park that was heavily developed. And in building the High Line, most of the train tracks and the things that were sort of the natural substrates where the lichens would have occurred when they came in on their own were removed or altered and moved around in some way. And so the fascinating thing is that I went back, I was fortunate enough to be allowed to go back in 2019 to go to the one area that actually still had intact roadbed from the old train. And what did I find? I found 10 species of lichen, including most of which, or all of which, were not found in 2004, and were not the one, or one of them was the one that Jessie found in 2017. So there was an increase in the High Line, but you had to go to the undisturbed habitat to find it. And so what this really gets at, by the way, incidentally, if you're curious whether the death of the transplanted lichens is something that happened in the past as well, we have a pretty good sense of that because Ernie Brodo, again in the 60s, he tried to transplant stubs of lichens from out in eastern Long Island into the city, and they all died very rapidly. And so, again, it's another hint that trying to move these things, they don't do so well and they don't generally become established and survive. It's a very different story than you potentially see with plants and animals. And that's because these things are so highly sensitive to where they grow. So, So we have these comparisons and we know that lichens have increased pretty substantially actually since the 1960s. There's over 100 species in New York City today. And you can consult Jessie's paper. It's actually available on ResearchGate, and anybody can email me or her for it, and I can send you a PDF. What's really interesting to me is that even though we know we have less species than in the past, and they've declined in abundance, and they're different species than we had in the past, or at least some of them are compositionally different, the overall profile of the lichen community looks the same. So this is a comparison between the profile of species in New York City on the left, and then, sorry, I have to always remember which one's right, which one's left, and then a comparison with several other areas, New Jersey, North Alabama, the Southern Appalachians, Indiana, the profiles of those communities as well. And what you see is that about half the species consist of crustose lichens. Those are the ones that are painted onto the trees, firmly attached. They can't be removed. crustose. That's one of the three main growth forms. So when we think about characterizing lichen communities, we think about the forms that they take. It's akin to saying trees, shrubs, and herbaceous plants. So about half the species in New York City, just as in all these other areas, are crustose lichens. You know, another maybe 20% or so, 20 to 30%, those are foliose lichens, the leafy ones that are separated from their substrate and attached by little root-like things. They have an upper surface, they have a lower surface. Again, they're about 20 to 30% of the diversity in New York City and in other places. And then finally, somewhere around maybe 10 to 15% of the species, those are the fruticose lichens, the shrubby ones that are three-dimensional. You know, they really stick up or down from the substrates that they're growing on. Those include the British soldiers, the old man's beard, the really iconic species that like a lot of people think of when they think of lichens. It's interesting that the iconic things that we think of actually comprise the minority of the communities and diversity in most places. But this is just one way to sort of get a sense of the fact that, you know, even though we know we lost our lichens by the 60s, and we've gained some back by now over the span of, I guess now 50, 60 years, it's fascinating that the communities that we see, even though they're different in terms of species and different in terms of abundance, it's interesting that like functionally, or just if thinking about them conceptually, they're pretty similar to natural communities that you would normally find. And that's interesting because we know that lichen diversity and lichen abundance and lichen communities are very strongly driven by habitat quality and by disturbance. And so this is a graph that shows the number of species found in 207 plots that I studied across the Southern Appalachians with a team of colleagues from the University of Colorado and the New York Botanical Garden. Each one of those red dots is a site. And we score the site in terms of its habitat quality using a bunch of different metrics. If you want to know about that, I can tell you about that another time. But the point is that we know from this and from many other studies that have been done in the past that lichen diversity, abundance, and lichen communities are really strongly driven by the quality of the habitat, how polluted it is, how old the trees are, you know, these different things that really, you know, get at, you know, is it an old growth forest basically? Is it an undisturbed environment, or is it, you know, one that is highly disturbed? Is it one that's highly polluted? We know that lichens are really strongly driven by that. The more disturbance, the more pollution that you have, the fewer lichens that you have, and different cohorts of species as well. So that's why what I find is really interesting is that the lichens that we have today, the communities that we see today, mostly represent species that have become adapted to the urban environment. And they're species that I would argue have almost entirely made it here on their own rather than being assisted by human, you know, help, basically. And the High Line really is a great way to conceptualize that. You know, we knew that there were several species there in 2004. It became a park. It was completely, converted essentially into this very aesthetically pleasing environment that's enjoyed by many people, including myself, and I suspect some of you. But nonetheless, you have to go to the least disturbed, the most intact part of the High Line to find all the lichen diversity that's there. And it's all species that I would argue have almost certainly made their way there on their own. They've dispersed there somehow from somewhere else and become established on their own. So it's interesting that among the cohort of 10 or 12 species that I found there, one of them was even a new record to New York State, this little endocarpon petrolapidium here. It's a face only a mother could love, I guess. So lichens in New York City, as in many urban areas, are highly adapted to urban living. And, you know, as I guess we are as well. And so they've become part of these really diverse communities that have sort of come to exist in urban ecosystems. You know, urban environments are very different than rural and sort of natural ecosystems, but yet they have all similar and components and similar functioning. And you can see that when you look at places like the High Line or at any number of New York City parks or really anywhere. You can see that there's these really diverse communities that are natural, in many ways. They have all the components. They are a microcosm of the environment. They have plants, they have lichens, they have mosses, they have microbes, they have algae, they have invertebrates. They're doing all the things that an ecosystem does. So lichens really are a part of this urban experience, and they're a part of the urban experience, the urban natural world that we experience, that has come to be on their own, unassisted by us, which I think is really fascinating. Basically, it's the ultimate story of, despite everything that we do, somehow nature will persist and organize itself to survive. So what's really interesting is that, again, we know there's this really strong correlation between lichen diversity, abundance, and urbanization and pollution and disturbance. And we also know that the lichens in cities are much smaller numbers of species and different species than would occur elsewhere. So what's surprising is that there's almost no resources to identify them. But that's true generally of lichens. And so, I'd like to just go through now the identification resources that existed up to relatively recently. The first major works on lichens in North America were from 1882 and 1888. There are 2 volumes, one of which was actually published after the author died, by the father of lichenology. They're really the only synoptic treatment of lichens for all of that covers all of North America, the United States and Canada, including New York City, obviously. And in fact, collections made in New York City at this time were included in this work as part of the distributions of the different species. There was a flora from 1910 for Minnesota. There was another flora for Southern California and Los Angeles County in 1913. Almost all of these resources, considering their age, didn't have very many photographs, certainly, or images or things like that. Almost none of them had identification keys. Most of them had distribution discussions and descriptions of the species. The only flora for the United States was published in 1935, again, after the author had died. It had keys and distributions and distribution discussions and descriptions, but it didn't have any images or maps. So again, if you're trying to identify a lichen from anywhere in the United States, basically the only resource that you can use today is this one book from 1935, that actually covered the entire United States. There was a flora of Washington in 1950. There's a flora of the Black Hills in South Dakota in 1967. I think it should strike you as pretty amazing that I just jumped from 1882 to the 60s. Ernie Brodo's treatment of the lichens of Long Island is actually one of the few resources that is available. Again, it includes distribution maps. It actually had identification keys. It's from the 1960s. Unfortunately, it's become outdated now because there are a lot of additional species that occur in this region because the area has changed so much with the increase in air quality. And just in general with the change in knowledge of lichens. There's one flora of the lichens of Arctic North America from the 80s, that's by John Thompson. And then finally, there's a flora of the Sonoran Desert region from the 2000s. That's pretty much the most up-to-date and modern flora for really most any region. Ooh, I'll admit that person. There we go. Of North America. I think I have to go back. There we go. And so in addition to those like 10 books, there's some keys to parts of Pacific Northwest of North America. There's some incomplete keys to parts of Michigan, Florida, the Ozarks. And then there's some books for identifying the really conspicuous, big, showy lichens that grow in West Virginia or Ohio. But that's essentially it. And then there's Lichens of North America, which many of you may be familiar with. It's a beautiful book. It's basically how I discovered the world of lichens, really. And it's what opened up, the world to me, because there's so many beautiful photographs. I mean, it's a truly amazing book. And it's great. And it covers all of North America. The only problem is that it's not complete. And it's especially incomplete for urban areas where there's different species, and a lot of species look different from the way they would grow elsewhere, because, you know, the conditions in a city, as we know, are the conditions for survival and the environment are very different than they are outside of the city. And the lichens are impacted by that. And so, you know, overall, what you have is you have for lichens, 5,000 some species occur in North America. You know, we've been studying them for over 2 centuries at this point. In North America, we have one flora for the whole continent that's over 100 years old. We only have a few little floras for states and regions. Most of those are more than 50 years old. Modern treatments are almost entirely for these big showy lichens, and they don't cover the tiny crustose lichens, the ones that actually make up, well, I think they're the most beautiful, but also they make up more than half the diversity, including in New York City. Most of the things that included crustose lichens are not complete, and they're very technical, and they don't include photographs. And then beyond that, just most parts of the United States have never been treated. And without a doubt, the biggest gap in all of these resources is cities, urban areas, the places where most people in the United States live, have no way to identify the lichens that are in them. And especially because the lichens that are in cities are different from the ones that occur outside of cities, and they often look different when they do occur outside of cities. So it's a huge problem that we decided to overcome. So Jesse Allen and myself, together with my graduate student, Jordan Hoffman, put together a field guide to the lichens of New York City and other urban areas throughout Northeastern North America. And it's, oops, I just realized press is misspelled there, sorry. Apologies to Yale Press. The book is currently in press with Yale University Press. And so this one is slated, I believe, to be out in fall of 2021, so this year. It should be in the summer, I think, catalog from Yale. But it's a book that will really, I think, you know, Jesse and I and Jordan really hope that it's going to open up the world of lichens to the huge community of naturalists that exists not only in our city, but elsewhere as well. You know, the thing is that it was really focused around New York City because that's where we live or lived, and it's really it was originally focused on that. It just so happens that the same cohorts of species occur in so many other areas, and there was no way to identify them before. So it's really usable in other areas as well. You know, Boston, Washington, D.C., Philadelphia, Toronto, you name it, Ottawa. You know, this book includes a whole lot of introductory material. So when you all can access it and can get it, you know, it has a review of the lichen lifestyle, the biology of lichens and how to identify them, sort of the history of urban lichens, especially as they relate to New York City, how they're impacted by air pollution, how lichens are used. They've been used for all sorts of things, from dyes to, you know, potted plants, as you can see in the lower right-hand corner there. That's a dyed lichen from somewhere in Manhattan. You'll often find dyed lichens in sort of potted plants and Whole Foods and things like that. They're used for all sorts of things that many people might not think necessarily. Train sets, they're the little trees and model train sets, or at least they used to be. How they're used by animals, how you find lichens in New York City, how you can find 50 species with one Metro card in a day, things that look like lichens but aren't, and then finally how to sort of collect and identify lichens. So that's the introductory material, but I think the best part of this book is really going to be, for most people, the treatments of more than 60 species, which are the ones that you will see day to day. And so this is just a mock-up of the species page. This isn't actually what the book looks like in terms of their art and design, but each species is treated in detail. So you have description, you have where to find it in New York City and in general, how common it is, how to identify it in terms of like how it's compared to other species. So this is the entry for the common green shield rock, this is rock green shield, Flavoparmelia baltimorensis. This is the green lichen that grows on a lot of rocks in New York City. There's some really particularly nice patches of it along the Central Park, or the road in Central Park near the Harlem Mirror. I was really shocked to see those when I used to go running when I lived on the Upper East Side. So it's not just, that one species. There's color photographs with scales, be it a MetroCard or a coin, for, over 60 species. And I think that that's going to be a tremendous boon for people, because it's really going to make it so that you can have a way to identify the things that are in the city without trying to use a field guide for another area that includes way more things that also, and then also the species that are here, but they look different than they would in the city. So I think that this will be really useful. Also, a glossary, illustrated glossary, and the diagnostic features for the species. So for instance, there's two species of lichen, Xanthoparmelia conspersa and Xanthoparmelia plittii. They look pretty similar externally and from the upper surface, but the way that they're distinguished is the color of the underside. And you can see here that the one on the left has this like dark blackish central part in the underside, flipped up there with a little pair of tweezers, whereas the other species, Xanthoparmelia plittii, it's pale throughout. There's some dirt attached to it, that's why it looks dark brown there. But the point is that without the dirt, it would be almost black on one and then pale uniformly on the other. So again, these are pictures that just weren't available before, more or less, and certainly not concentrated together in a single field guide dedicated to urban areas. There's also a complete key to the lichens in New York City. So it's over 100 species. And this is actually a key that specifically I designed to be used with macroscopic features in terms of with a hand lens. So you don't need a dissecting or, well, you don't need a compound microscope to identify these lichens. It's amazing to me that you can actually identify most of the species in our region this way. But again, that's because we have a relatively selective group of species that occur here. So for instance, I did obviously choose the easiest one to show you. That this is the common candle flame lichen, Candelaria concolor, grows on rocks and trees throughout New York City. If you see a yellow lichen growing on a tree on the street above the pea line of the dogs on the trees, it's Candelaria concolor. And then you can see in the identification key, it would be pretty easy to get to it. It's actually the fourth or third option there. You have to know that the thing is leafy. So that would get you from 1 down to 2. You know that it's yellow or orange, so that would get you to 3. You know that it's on bark or wood. Actually, this one's on rock, so you'd go to the one on rock. And then if it's crustose, it's crustose, and if it's foliose, it's foliose. This one has lobes. They're lifted up from the substrate. It's a foliose lichen. Wow. It's pretty easy to get to Candelaria concolor. I assure you it would not be this easy in a book that contained all of the lichens that occur in North America. So again, it's because there's many others that just don't grow in cities or don't occur in the northeastern United States and eastern Canada. And so with that, I would like to thank all of you for coming and thank all of the amazing folks at the Botanical Garden and at the City University of New York and Fordham who have worked with me over the years, and Jessie Allen, who really led the project to put together this book and restudy the lichens of New York City. She's the one who sort of ignited my passion to sort of see these things that are coming in on trees and rocks and stuff, and how long they survive, and just sort of I guess I always had my botanical blinders on when I returned to New York City, and I'm glad that someone helped me take them off so that I can actually see the world around me, where I spend most of my time. And then tons of collaborators, from Central Park and CUNY and the Philadelphia Botanical Club, the Torrey Botanical Society, Woodlawn Cemetery, and of course Yale University Press. The folks there are really, we would not have been able to produce this book if it hadn't been for our editor there and for the other staff there as well, who really supported lichens, love them, just like many do, and hopefully you do as well. And so with that, I guess I will take questions. Maybe I turn this back over to, do I have to stop sharing? Yes, there we go.
Great. Thank you, James. If you'll use the raised hand feature that you look in the participants pane, you can.
I will merely note you have access to a full complement of emoji. It's not just the 2 that used to be available in Zoom.
Okay, right. You could clap your hands or thumbs up. Like, there we go.
I'll open the chat up on my window.
Yeah.
Thank you so much. I appreciate the yes.
Okay,
It's not the
Stephen
same
has
as
a
being in
question.
person, but at least we can use emoji.
Hi, smile emoji, thumbs up emoji, and an applause emoji. So I was wondering, you said that the lichen was basically extinct, but looking at the maps in iNaturalist of what people have found in New York, it seems like a lot are in Jamaica Bay, Floyd Bennett Field, the Greenwood Cemetery, and Staten Island. So these seem like were they even wiped out in those areas as well?
So I think the answer to that is mostly yes. The areas further out in Queens and Brooklyn and the Bronx, probably less so. They still would have been greatly impacted, but it's interesting. Floyd Bennett Field is the only place one of the few places that still has kind of pretty intact lichen communities that I think are similar to what you would see in the further out Long Island pine barrens. So it's a little bit of an exception because I feel like on the fringes, things were a little bit less impacted. So some things probably did persist there. But in terms of closer in, if you look at the maps in Ernie Brodo's book, which unfortunately I don't think is online, it's really annoying to me. It's a New York State publication, right, Cuomo? Like that's something that should be online for free. But he really did look in the city and there was like nothing there. He was explicit, and I have discussed this with him, that there was nothing in Manhattan at the time. There was one species in Brooklyn Bridge at Brooklyn Botanic Garden. There might have been one or two in the Bronx. We have some historical records that indicate that there was some stuff around back then, but by and large, I think it's like, if you're going to simplify it, just say it was all wiped out, because that's pretty much what happened. It's just on the fringes and in some unusual circumstances where something might have survived, but by and large, that's not the case. And it would have been in natural areas that did remain intact during that period.
Thanks, amazing.
Sure, does that does answer that?
Oh yeah.
Yeah. Someone else?
Well, I'll ask a question, James. And I wonder if there's enough data that's known now to be able to track the lichens in a little bit more real time. The work that you and Jesse did, the historical research to, show how the lichens declined and now they've gone back up. But that's at a fairly coarse scale.
Coarse. Yes.
Very coarse. I wonder if you have any sense or any ability to track it maybe by a little more closely by decade. And the reason that I'm curious about this is because air quality is not static. It's constantly changing. We're cleaning up our cars and we're putting scrubbers on power plants and that sort of thing. But we're also introducing other kinds of pollution. There's fracking going on. Now people are talking about geoengineering and actually pumping sulfur into the atmosphere to dim the sun. And we know that the lichens are super sensitive or especially the algae, super sensitive to sulfur. So my feeling is that we might have seen a peak in the abundance and diversity of lichens now, and it might actually start going down. I hate to be a downer after such a beautiful talk and, just celebrating
I
the
think that's
diversity of lichens.
That's a valid thing, and that's a concern I share for sure. Not just like pumping sulfur into the atmosphere, but just in general. I mean, I think it's really important you know, I try not to dwell on the sort of downside of like, well, we have way less of what we had than what we had originally, because it's truly amazing that things have come back. And what's coming back is adapted to be here. You know, we know that that's the case. And actually a colleague of mine at Fordham who studies urban evolution and I are specifically, you know, we have a project that's getting started looking at that in New York, looking at how the lichens have adapted from a like genetic perspective. Because that's the basis of presumably how it's happening. But, you know, I think it's really important where that's what all of these iNaturalist observations, and that's what people being in the same place, documenting the same thing over time is so important. You know, it seems, I think maybe it seems silly to people. The reality is I am one human being and I have only so many hours in the day and I can't be everywhere all at once. And thank God, that's why we have people, you know, all around that do take pictures and can document the things that are around them over time consistently in a yearly fashion. Because like we don't even know what the growth rates for a lot of these species are in urban environments. So, you know, taking a detailed image, a high quality image of the same thing over and over again over, you know, a span of years, it might seem like nothing changes from year 1 to 2, but from 2015 to 2020, the lichens on that maple tree completely disappeared. You know, and it's a gradual, so it doesn't look much, but it does change. So that's why you know, I think it's a huge role for citizen scientists to play. But you know, it's also something that the reality is there's not very many lichenologists, there's not very many positions for lichenologists, and you know, there's not a lot of funding necessarily going around. So it would be great to have a project to do something like that. I did propose actually to do something along those lines with the COVID epidemic to the National Science Foundation, but they said that we could fund that project regularly rather than with the special COVID money. But you know, during COVID, there was a significant drop in air pollution. And I think that there's a question of whether or not what I wanted to do was sample right at the beginning of the epidemic and then see how the communities changed over time and whether or not that correlated with the downtick and then subsequent upturn if it occurred in air pollution. The relationship between lichens and air pollution is a little complex. It is more or less linear, but things do change. But I share your concern. We might have seen the high point for lichen diversity in New York City and other urban areas and maybe in general. But I hope that's not the case because it's a sad future if it is.
Yeah, I think we all need to advocate for cleaner air and more lichens.
Yes, yes.
Definitely.
They go hand in hand. Everything
right.
good involves lichens.
I have a question.
Yeah, I think Molly was next.
Oh, I'm sorry.
Yeah,
oh, sorry,
Molly
I didn't
was
see the little
next.
hands. Yeah.
Yeah.
Hi. Hi, can you hear me? This is Molly.
Yep.
Yes.
Hey,
Hi, James. Nice shirt.
Thank
Great
you.
talk. Listen, is there still any point in obscuring certain lichens because there are crazes? There is an absolute internet craze for pixie cups.
Yes, that's why.
Yeah.
I think it is important to do that for, you know, something like Candelaria concolor or Flavoparmelia, the ones that are common that you see everywhere. I don't worry about that too much. But something that is rare that you only see once or that's in a little patch somewhere, I would obscure that. And, you know, like, I think for someone like me who does do more work in like wilderness, whatever ecosystems where the species I'm working with are like critically endangered, you know, worldwide, you know, it's the same thing. It's just in a different context as that. And we obscure those data. So why wouldn't you want to obscure that?
Thank you.
But that being said, I mean, it's obviously important to have those data somewhere. And I am interested, like I do maintain records of that kind of stuff for rare species. I mean, that does need to live somewhere. And I do keep records of that just because it is part of the larger scale conservation work that my colleagues and I are doing. So, you know, I do my best to respond to emails. So, to which Molly,
You do. It's amazing.
So I'm always interested to, you know, if someone finds something and it's really, look, it's people going outside and looking carefully who find the things. Like, it's not going to be, maybe it would be me walking down like 23rd Street at 10th Avenue, but like chances are it's somebody here.
Thank you.
I'd also like to just note that Molly really, and the class that I taught at the New York Botanical Garden, which was supposed to happen last year, but for COVID, really helped with improving the keys for identification. You know, the people that participated in the class in, I guess it was 2019, and Molly subsequently really did give me a lot of sort of helpful edits and comments that I think made the keys a lot more useful in this book. So I really hope that people will be able to identify the things now, you know.
Thanks. Your key has already changed my life. Really looking forward to the book.
Lichens are life changers.
Yep.
Okay.
Okay, Ken has his hand up.
Hey, hello.
Hey.
James, thank you very much for an excellent presentation. That was just terrific.
Thanks.
Here, I'll come on and give you a wave.
I wish you would.
So I'm curious to know more information about the specific lichen species that has a sort of a symbiotic relationship with the lacewing. I think if I heard you correctly, you mentioned that the lacewing only uses one very specific species. So I was wondering what that was. And also, on the other side of the coin, do you happen to know which family of lacewings that is? Is it the green or the brown lacewing?
I don't remember off the top of my head. I think it's green, but don't hold me to that. I'm sure if you Google around, that information is available. It's that they only use, as far as I know, they only use dust lichens, and so that's one genus of lichens. And someone else actually might be able to prove me wrong here, but my understanding is that that's pretty much what they use. They're common. I mean, the dust lichens are pretty disturbance tolerant things, but it's specifically the genus Lepraria.
Got it.
And I suspect that's because they're kind of, well, part of it is that they have these chemicals in them that make them hydrophobic. So they probably repel water. They're also like antimicrobial, antifungal chemicals. So that might confer some kind of benefit to the invertebrates as well. And then also, you know, there's just the fact that things don't see them and so don't eat them.
Yeah, I've seen lacewings with all sorts of debris on their back, including what looked like lichens. I was not sure of the species, and I just happened to pick up the Kaufman Guide, Field Guide to Insects of North America, and on the lacewings page, it does show a larva carrying debris, and it looks just like
the picture I showed.
Oh, was it that one? Well, hello. I thought I discovered a coincidence here.
No, I mean, there's different lacewings that use different things, but I think there's the species that do use the lichens use them preferentially. I mean, I'm sure there's some that are adapted to use other things. I'm, you know, full disclosure, not a lacewing expert.
Me neither, but I do find it fascinating that they use this as a camouflage, basically to hide from the ants while they're preying on aphids.
But it's not just that. It's like there's so many insects out there that, especially in the tropics, that mimic lichens that are, I've seen pictures that like colleagues that study insects have taken that are just insane levels of mimicry. Like, wow. It's not just like lichen grasshoppers, which many of us may have seen, that occur in our region, or things like that. Like, these are things where like they grow crazy protrusions and the colors and everything look just like an old man's beard, or I saw a leaf insect that looked just like a foliose lichen. I mean, it's just crazy how they do that. So it's, and obviously that's a very specialized relationship if the insect has evolved to look like the lichen and a specific kind.
Indeed. You'll have me Googling that later tonight.
Please do.
Thanks, James. Thanks for an excellent presentation.
Sure. Molly, did you have another comment?
No, I just wanted to, I think I have a video of the lacewings on a naturalist.
Share the link in the chat.
Okay.
Anyone else?
I have a question, but I don't have the little hand raise icon on my
I
screen.
think we'll let you ask it anyway.
Yeah, go
Thank
ahead.
you. Thank you. My name is Judy Jacob. So you had a couple of graphs where you marked time sort of beginning with the 1960s.
Mhm.
And things changed in the 60s.
Yep.
The Clean Air Act was established in 1970.
Mhm.
So what happened in the early 1960s that was somehow different than the 50s and yet different again from 1960s?
That's just sort of a generalization time frame. It was basically 1970 onward. It's just that most of the baseline data for prior to the Clean Air Act is from like around the 60s. So
Okay.
I just when I talk about it, always post and pre 1960.
Okay.
It's not it doesn't have anything to do. I mean, basically it's entirely due to cleaning up air quality.
Which started in 1970.
Yes.
Right.
Yeah.
Okay. Thank you.
And improved significantly over a period of time, and has now, and it's not, the thing again is when I talk about this and when anybody thinks about pollution in general, and most trends over time, we talk about them in these like broad generalizations, but the reality is that how pollution has impacted a specific place is very different from another place. And I actually didn't fully appreciate this until recently, looking at pollution variables over time for several decades in North Carolina and Tennessee, where I was working with a graduate student of mine. And it's really fascinating because, you know, the trend overall can be like this, but there's a lot of differences at very local levels. And that definitely has a strong impact on the lichens. The other thing that's important to think about with air pollution is that it's the overall trend, we think, and actually I have a student that's studying this. We think it's the overall trend that matters the most, because lichens are only physiologically active when they're moist. So like, I think it's like 60 to 80% sort of wetness is when the green algal ones are sort of photosynthesizing and metabolically active, physiologically active. When they're dry, they just shut down. And so like if air pollution comes when they're dry, if a cloud of whatever passes by when they're dry, they don't uptake it because they're not active, they're not wet. So it just goes on by. But if they're wet, then they will uptake whatever is around them in the environment. And so I guess that's sort of something to think about, is that that's why I think a lot more has to do with the long-term trends, because just sort of chance occasional impacts from pollution have potentially less of an impact on lichens in the communities rather than the long-term trends. And that's incidentally why acid rain was so bad for them, and is so bad for them, is because the rain makes them wet and then they become active and then they intake all the pollutants and die. That's acid fog in the Southern Appalachians is one of the reasons why they were so decimated there. They've come back, but they were not doing very well.
Thank you.
Sure.
Jay? You're muted. There you go.
Okay. Thank you so much for the presentation tonight. Really great. And I'm wondering about methods for documenting change in lichen coverage on a tree trunk or something like that. The iNaturalist thing is just sort of point data things, and I'm wondering how we might gather and share that kind of data, and also thinking about sides of trees. In an urban setting, I notice around my place that it's not always the north side of the tree. It's all about moisture, shadow of buildings, prevailing winds. There's all kinds of things I feel that are affecting the growth.
Yeah, the north side of the tree thing is a misconception.
Yeah.
like so many things, it's a truism. But yeah, so actually the thing for documenting over time is having, like, we actually, you can make a little like window frame, a little frame out of something, or you can just buy a frame somewhere for very cheap. That doesn't have, just take the plastic, because it's probably not glass at this point, out of it. And then just use that over and over again, in the same position. It's harder to do that on a street tree. If it's a tree that is on your personal property, you could put a little nail in there. And then you can hang your frame from the nail. But at least with the thing with like photographs, and especially with a smartphone or something like that, is you can have the picture available from before, and you can say, okay, well, here's the points where I was at before. It's never going to be exactly perfect, the same all the time, but having a relatively close-up snapshot of the same, more or less square over and over and over again, months, years, is the way to go. I mean, I did it with that Japanese maple. Pick a part of the tree that's obvious and like where your eye goes there because there's a, I don't know, like a branch or something, and that's where to do it. So you always have that landmark to do that. And then if it's a little farther away, a little closer, that's not the end of the world, as long as there's a scale in there somehow.
And are there any thoughts about sharing that? Does that go into an iNaturalist post somewhere? Where would you track or compile that?
I don't, Daniel, do you have a thought on that? I am honestly not quite sure. That's the kind of thing where like I'd probably get involved after that's been done for a little while. Picture number 15 is when well, not years, maybe 5 years, but like long enough to see change, which will occur doubtlessly. So I'm not quite sure where I would recommend you. Why not iNat?
I think that's a great place for that information. I often take the same plant, year after year. It shows that it's still there. It's maybe it grew a little bit, got taller. So yeah, and iNaturalist is free, or hopefully we contribute a little bit to its maintenance, but it doesn't cost, virtually free, and we don't have to maintain that information. So hopefully it will be preserved. And if it's a research grade observation, it will get uploaded to GBIF, which is a global database of biodiversity information, and that presumably will be preserved as long as human beings are, sitting in front of computers. Don't know how long that will be, but probably for most of our lifetimes. So this information will be
as little as possible.
Yeah, right. But it will be preserved there. So iNaturalist is a great place for that.
There isn't a tag that already exists on iNat, is there? Lichen frame shot.
You
could create one that's opportunity there.
Well, and once there are repeated observations, so I probably wouldn't get involved myself in terms of archiving for a single image, but once there are multiple years, we do, there are ways that can be archived elsewhere as well. Like for instance, the work that I do in the Southern Appalachians, we have as part of the project that we have, we're collecting these swabs of environmental samples to sequence the DNA from, and we have a little plot that we put on the tree, and then we scrape all the stuff on the tree, and we photograph that before we scrape it with a toothbrush, and that photograph is associated with that point in time and space and uploaded to our database at the Botanical Garden. You can't access it through the virtual herbarium, it's through a different web platform that's in there, but the point is that it is archived in there. So, I mean, there's a way to do it, and I personally think that if you have yearly observations of a thing, it's incredibly important to be able to look at that over time. It's hugely valuable, and it's the kind of work that people like me, for some reason, just don't tend to do. I don't know why, but
You can't get a grant to do that. NSF's not going to pay for it.
not for maybe 5 years, but not for prolonged periods.
Right.
But again, I think the value of it is that it's often easy. The only time it's easy is if it's doable, is if it's easy and in close proximity. And then what becomes valuable is having that point over time magnified by lots of points that different people have done in different places over time. It's not just the one, it's thinking about it in aggregate over time. You'll see the trends.
Right. Well, we have time for a couple of more questions. I hope we can get Megan and Susan. Susan, I think you're next. It's okay.
Yeah, I'm kind of interested in doing this documentation, but I would be more interested in doing it for something that James would be more interested in. I wonder if after this lecture, the people who are on the Zoom might get a list of the lichen that James is most interested in having some kind of documentation on, whether we use like the little frame or whatever we use. I have a couple of residences and I would like to, I think this would amuse me to do through a period of time. But I'd be more interested in knowing what you're interested in.
I guess I'm not interested in specific species. I'm very diffuse, in case you can't tell. I'm not interested in specific species so much as trends overall. And so that's why, in the New York metro region and its outlying suburbs and whatever further out than that, there's only a subset of things that grow there on trees or rocks. And so what I'm curious about is sort of how those all change over time. And especially in the city, it's really when I would just love to know, when you move something in here, how much of it survives and how long does it take to go away? I have like 1 point from 23rd Street, 1 point from 14th Street. It's the places that just sort of, I happen to see something and I'm not here all the time. But like people who are frequently here and walking and doing things, I also don't take a camera with me when I go running. So otherwise I'd probably document things more frequently. But if someone that is doing that, that's like, to me, that's a potentially huge contribution. If you're walking in Central Park every week almost, or every month, pick a tree that has a lichen on it that particularly attracts you, that you think is interesting and appealing for some reason, and see what happens to it over time. It's like there's really no information. So I know maybe that's not helpful because I'm not good at providing specific direction here in terms of the content. But it really is just that there's almost no information. It's crazy to me, but that is the case.
Yeah, I think what would be really important is that it's convenient for you and
Yes.
that it's kind of obvious, because
Yes.
if it's inconvenient or out of the way, hard to get to, probably is not going to last very long. So should be kind of obvious and convenient. Let's take Megan's question.
Mine's less of a question and actually just a plug for everybody. It's kind of going on Jay's comment of what's the best to use. And I really wanted to say to use iNaturalist, because I don't just document, for me, like I'm documenting the lichens that I run into, but I'm trying to make a point to go back to the ones that I've seen at the previous years. But also when I'm in an area, I look on iNaturalist for other people's observations. So I do try to go out to take those. So I recommend people to keep on iNaturalist. Also use it not just to document your own, but really investigate it as a user to go, well, what's around me? There's that sort of feature of, to search on your phone by species and location, and you can be by me and, zero in on a map. So I think you can help other people who might not get back or whatever, and you can so that's just my plug, is to keep using iNaturalist until gets, taken out by a earthquake or whatever.
I mean, it's the best aggregator of information like that. I use it when I want to find something. What I use. If I want to know what time of year the grazed lilies are blooming on Roan Mountain in Tennessee, it's INAT that's going to tell you.
Right.
Yeah, and they have beautiful maps. I think they do the GIS really, really well.
Yeah, it's quite nice.
It's very easy to use. Well, I think that wraps it up. James, thank you so much. I know we all enjoyed your presentation very much, learning more about lichens. Yay. This presentation was recorded, so we'll post that, send out an email on that shortly. And so you'll be able to review that. The people who are not here, you can tell your friends. They can review that later. Please join us for the Upper West, or the Community Board 7 Parks and Environment Committee meeting. Those of us that regularly attend, that's the Monday, the 25th of January. And they'll be talking about partnership for parks, and I think Riverside Park is on the agenda as well. So undoubtedly they'll be discussing things that impact nature. So as the voice for nature in our community, it's important that we're there to advocate. So with that, let's wrap it up. Say thank you to James, and we'll see everybody soon outside, I hope.
Thank you all. Thanks for coming.
Okay, thank you.
Y'all have a good night.
Night.